Okay. No, PPT I can manage, no problem.
Yeah.
Okay.
Ma'am, shall we start?
Yes,
Yes, please.
we'll go with this.
Okay. Okay, sir. Thank you. Good morning, everyone. Mother Earth is a living organism to love, honor, and respect her. On behalf of Nazareth College of Arts and Science, it gives us a pleasure to welcome you all for the second day conference on restoring Earth to normalcy. Prayer is not asking, it is a longing of your soul. I believe that prayer is our powerful contact with the greatest force in the universe. Let us begin this session with a prayer.
Mercy drops mountains on the showers with showers of blessing, graciously binding again over the hills and the valleys. Mercy drops mountains on for the showers we Mercy drops mountains on for the showers we
It's a welcome we bring to you this morning, filled with the desires, hopes, and dreams all of us share. We now request Ms. K. Alamailu, Head, Department of Mathematics, to welcome the participants.
We can't hear anything actually. This is Archana.
Yes, ma'am.
Yeah. It's not audible.
No, ma'am.
Good morning to all who are gathered here. Good morning. I extend a very warm welcome to Dr. Kashyap. I extend a warm welcome to Section 1 Resource Manager at Cheetah International Airline. I welcome our resource person, Dr. Ramesh Chinnaswamy, Professor, Thailand of International India. Welcome, sir. I welcome our honorable L.P. Harris. Welcome, sir. I am pleased to offer a welcome to our honorable principal, Dr. E. Mary Angeline. We welcome you, ma'am. I also welcome our beloved Vice Principal, Mrs. E. Manoranjita. We welcome you, ma'am. I extend a warm welcome to the coordinators, faculty members, and participants who have joined with us here. Once again, I extend a warm welcome to one and all present here. Thank you.
Thank you, ma'am. Now I request Dr. R.R. Krishnamurthy, Associate Professor, Department of Applied Geology, University of Madras, and Director in charge, UGC HRD, UNOM, to give a keynote address.
Okay, very good morning to all of you. And we are continuing our 3 days event. And yesterday we had two important speakers. They highlighted about the importance of the restoration of Earth to normalcy. We had a discussion about the importance of biodiversity and the conservation of biodiversity in the session one, and followed by the water that the Earth ecosystem, how it is impacted by the various human activities in the session two. Yes, I'm audible.
Yes, sir.
I'm audible. Okay. So rest of the participants can unmute your mic. Sorry, mute your mic. Mute. Okay. Actually, this unexpected thing happened. Dr. Shivkumar, this today's speaker, is not available. So in standby, I am going to engage this session, forenoon session, up to maybe 11 o'clock. So this first presentation can go up to 11. No? As per the schedule. Okay. I'm saying it is highlighted about keynote address, and then up to 11,
Yes, sir.
right? And then the poster session is going to start by 11. Okay. I'll engage the participants till 11.
Yes, sir. We
We
Krishnamurthy,
need
sir.
not, yes, we need not worry about
Yes, sir.
the speaker.
Yeah, thank you so much. And we will sort of shift the invited posters soon after you finish.
Okay,
We'll
no
just,
problem.
yeah,
No
okay.
problem.
We'll
No
fill up the
problem.
gap. Thank you.
Okay, I'll manage the session up to 11 o'clock. Let the poster presentation students be ready to present at 11.
Yes, sir. Yes,
Okay,
sir.
okay.
Yes, sir.
I'll straight away go to my presentation, and then I'm going to engage the participants in a different manner, that with reference to the coastal ecosystem, and how that the coastal ecosystem is being experienced due to various human activities, how those ecosystems being managed. So that is going to be the today's presentation in place of Dr. Shivkumar. Let me share my screen. Uh, I think you have to enable me to share the screen. Okay, fine.
Yes, sir.
Yes, sir. It's visible, sir.
So the topic I am going to handle this session is coastal management. So what are the challenges and what are the innovations made in the country? Coastal ecosystem. Why we are giving much importance to the coastal areas and coastal ecosystem? Look into this particular slide. I am highlighting about the importance of our Indian coastline. So what are the important coastal system we are having? And you look globally, the entire global population, nearly 60% of the global population is concentrated on the 100-kilometer stretch of the global coast. So you see that the large number of population concentration, and another important thing is large number of coastal ecosystem that is being used for various applications, various purposes. So that is the reason behind the coastal ecosystem, addressing the coastal issues. And this is being considered as a multidisciplinary subject. And many researchers are working on these various aspects of coastal management. So what I am going to highlight in this presentation is whatever the efforts taken by the Indian scientists, especially to managing the coastal ecosystem and coastal environment very effectively using the technology tools like satellite remote sensing and the spatial information technology, etc. So looking into this particular slide content, you can very well understand the number of occurrence of important coastal hotspot. Hotspot is nothing but it is an important, it covers important ecosystem across the coast. So when you look into this 7,516 length of the Indian coast, we have varieties of coastal hotspot, the ecosystem, environment, everything available. That is the reason behind many of the
Good morning, sir.
Yes, good morning. Yes. Any queries? Any doubt? There is one Chandra Kiran. Yes.
No, I think he was just wishing you.
Okay.
Okay. Please continue, sir.
Okay. Right. The another important thing is when you look into this, the total area of our exclusive economic zone. Exclusive economic zone start from the coastline. It goes up to 12 nautical miles inside the seawater. That is our territorial boundary. So the total area of exclusive economic zone is almost equivalent to the land area of the country. That's, we have that much vast coastal resource. And you see that there are so many national parks, wildlife sanctuaries, and biosphere reserves. All these things occur along the coast. That is the reason behind we are focusing, we are giving much importance to the coastal areas and coastal ecosystem. When coming to the issues with reference to environmental issues, ecosystem, all these things, broadly, we can put all the coastal issues under the three categories. First one is coastal ecosystem degradation. Second one is the coastal pollution. And third one is the changes, alteration of the coastline. So these are all the three broad issues the entire global coast is facing as of now. And there are other varieties of issues are there that we'll be discussing, but broadly we are going to highlight about this. In my presentation, our case study we carried out in these following locations. I'm highlighting the map in which all our study areas highlighted and the locations are highlighted. So these are all the important coastal hotspots we focused during the last 2 to 3 decades. And we carried out varieties of studies along this, especially in this coastal hotspot. So my presentation is going to highlight about this. And I think, assuming that many of the webinar participants are social work graduates, the students and scholars, young scholars from this particular area, and you need to understand that the India is having a very strengthened with this technology tool, especially the satellite remote sensing. And India is one of the pioneering countries in the world and using this technology very extensively for various applications. Even our day-to-day life, we are depending on the remote sensing technology. When we use that, our navigation maps, this is also based on satellite image. So what are the important applications of this technology? And we can very quickly monitor in a particular area. and in a repetitive manner. So some changes, some area is undergoing some changes, some area is undergoing some kind of environmental degradation. Using this technology, we can very closely monitor those areas. That is the very important thing. So we can obtain this data in periodic manner so that the monitoring is very effective when you use this remote sensing, satellite remote sensing technology. And we have varieties of resolution available. Based study we can carry out, and then site-specific study also we can carry out. So whatever the changes are taking place within your college campus, that can be monitored very easily using the satellite data. That is the advantage of this technology, another advantage of this technology. And provides accessibility to inaccessible sites. What does this particular sentence mean? For example, if you go to the Andaman Nicobar Islands, you want to carry out some survey. Is entire the Andaman Nicobar group of islands invariably covered by dense tropical rainforest, and some of the islands is still having the original tribes. Those islands are inaccessible to outsiders like us. So how to make an assessment on the resources available such inaccessible sites? That is only based on remote sensing data. Even the 2004 Indian Ocean tsunami, we are in a position to make assessment only based on the remote sensing data because those islands are still not accessible. And another one is the technology will give you very fast and accurate information. Important advantages of this technology when you go for this kind of ecosystem and environment mapping and monitoring. And also it has the compatibility with the spatial information technology tools. Very often we used to mention that geographical information system, and this is widely available for various end users. Maybe many of you may be already exposed to this usage of this technology tools. Okay, coming into this usage of this technology, remote sensing and spatial information technology in our country. I'm just giving a highlight about the things happen since 1970. Only that time the Department of Space was established, and that time India was not having our own satellite, but India used to receive data from other countries' satellites. We are having a receiving station in Secunderabad, and from where we can get varieties of satellite data for the user departments. You can approach the National Remote Sensing Agency in Hyderabad. That is the agency responsible for providing the satellite data to the end users. And you see that looking into this particular table, I am just highlighting about the whatever the case studies, whatever that national level and regional level studies carried out in the country. I'm broadly highlighting here. There are various national programs were carried out since 1970. We used varieties of satellite data to prepare small scale maps. Small scale means it covers larger area. That is the very important things. And to understand what is the total land use, land cover available in the country, and state-wise, district-wise, and taluk-wise, likewise, we prepared varieties of information pertaining to the total land use and land cover. You see that the Earth surface having only the two categories. One is the land area used by human activity, that is we used to call it as a land use. And the natural land cover, we used to call it as a land cover. The forest cover is available, that comes under the land cover. So how that the land use practice, the land use area is expanding over a period of, there is very, very important things. The estimation of the area as well as the monitoring is very important. We used this kind of satellite data for the preparation of maps for the larger area. And the technology also gone to the level to identify where that the fish potential available in the ocean water. That is primarily based on sea surface temperature and what is the nutrients available in the seawater. Using those information, and India is one of the pioneering countries in using the satellite data for ocean application that helped the fishing community. Nearly 500 fishing landing centers received this information. Based on this information, fishermen used to go to the sea and for fishing. And that level the technology reached. And even after this 1990s, there is a varieties of program carried out in the country to prepare site-specific coastal management plan using the satellite data and the spatial information technology. And this is all the overall development happen in the country, especially towards the coastal management using the remote sensing and satellite technology. So as I mentioned earlier, I am going to broadly cover about these three important aspects: how that coastal ecosystem undergoing changes, and how effectively we can use the remote sensing technology to monitor those ecosystems, and how to study the coastal pollution both qualitatively and quantitatively, and to understand about the coastal hazards. So this is the three important parameters more and more helpful to go towards effective coastal management plan, that is integrated coastal zone management in the country. And I'm just going to highlight about the very important coastal ecosystem. Many of you are aware of that. The mangrove forest is a very, very important ecosystem, coastal ecosystem. And what happened, this ecosystem, especially during the 1980s, and people started thinking that this is something like a wasteland. It may not be useful to any purpose. So they started converting this mangrove wetland for agriculture, aquaculture, salt pan activities like that. So the booming of aquaculture happened sometimes in 1980s that heavily impacted on the mangrove wetlands. But later on, people started realizing that, especially the scientific community created a lot of awareness. They carried out a lot of studies to highlight about the importance of these mangrove wetlands. This is a very peculiar plant that occurs in the intertidal zone of the coastal area, and where the water condition is brackish water. Is actually the mixing of fresh water from the rivers and the seawater. This used to happen in this particular area. So the water is brackish water. In this particular location alone, you can find these mangroves. And the importance of these mangroves with reference to marine fisheries, this is acting as a nursery ground. So once you destroy this nursery ground, definitely it will have impact on the coastal and marine fisheries. There is one important thing. You know that considerable amount of population living on the edge of the coast, they are depending on fisheries for their livelihood. And you just think about that, what will happen once you destroy the nursery grounds. This is one important thing. The issue was addressed during that time by the scientific community. And another important thing is 2004, the people living along the coast, they witnessed the importance of this ecosystem. This is acting as a natural barrier against cyclone and tsunami. And in Tamil, they used to call it as Alayati Kadal. That means it will control the impact of waves. It will control the impact of this kind of natural calamities, disaster like tsunami and typhoon or the storm charges. This is the importance of this ecosystem with reference to natural hazard, with reference to marine fisheries. But what happened? So the unmindful exploitation of these resources happened during the time of 1980s. The scientific community started creating awareness about the importance of this ecosystem, how to restore this ecosystem. Why I'm highlighting about this particular topic today is we are all discussing about the restoration of earth, restoration of the environment, restoration of the biodiversity. So how we are going to restore this kind of ecosystem? This is a very biggest challenge for us at that time. So how to identify first to understand what is the area is available, this mangrove forest available along the Indian coast. So that is the role of the remote sensing technology that used extensively to map the area and how much area of this forest is available and what kind of change is taking place within this ecosystem. So I'm just showing the picture. Many of you may not be familiar about this, the background of this remote sensing technology, but try to understand very simple. I am giving a simple explanation that I'm showing this picture, the satellite imagery of 1987, starting from your left-hand side and the middle 1994 and coming into the right-hand side 1996 satellite imagery of one particular mangrove batch that is called Pichavaram mangroves in Tamil Nadu. Many of you are aware of this particular location. It is a very, very important tourist spot. Many of you might have already visited this area. The satellite imagery shows the red color batch within this yellow boundary circle, that is the mangrove areas. And you can see that a lot of changes within this mangrove ecosystem when you look into this comparison of the satellite imagery of 1987, 1994 and 1996. When coming to this 1996 picture, I am highlighting, I am moving the cursor over the image. The red color is nothing but it's a healthy, dense mangrove areas. And you see this immediately outside the mangrove, this comes under the reserve forest. This red color where we have the mangroves is a reserve forest. Immediately outside the reserve forest, we have the agriculture activities and so many human activities around this reserve forest. And this satellite imagery clearly shows the development of aquaculture around this mangrove reserve forest. It appears in the blue color, some kind of pattern you can see. This is nothing but the aquaculture prawn farms around this reserve forest. That happened of aquaculture around this ecosystem. Imagine that what will be the impact of these activities to this ecosystem, this mangroves. This is the one can understand the situation in this area. We have done lot of analysis, especially using the satellite data to extract the exact boundary of this resource and what is the total area and all these things. But as I mentioned earlier, this is a very unique ecosystem. It requires the proper mixing of fresh water and saline water, since it can exist only in the brackish water environment. So under this situation, just imagine that what will happen if we stop the flow of fresh water entering into this ecosystem. Many people used to think that the water carried by the rivers, it usually come from the mountainous area and pass through the coastal plains, and then it will finally enter into the sea. The discharge of water, river water entering into the sea, we used to consider that we are wasting our freshwater resource. But in our natural system, it requires the discharge of fresh water from the rivers to the sea. It is very much required for the ecosystem like mangroves. And without that mixing of this fresh water, what will happen? I'm just showing the picture. There is another patch of mangroves occurs in the Kaveri Delta, that is Muthupet, where we are having a lot of streams coming and entering into that mangrove area. We have the Muthupet Lagoon, and these are the streams which brings fresh water to this ecosystem. You see that this red batch mangroves started decreasing when we are coming to the year 1994 and started increasing in 1996. It gives a very indirect evidence that when there is a drought condition in that place, there is a limited amount of water, fresh water coming into this ecosystem. The natural filling is taking place, the area of mangroves getting reduced. So likewise, when the area is started receiving the fresh water, the natural regeneration is taking place. You see that there is a total drought condition in our Tamil Nadu state, especially from 1980 to 2004. In these 25 years, there are so many drought periods. Even you can see that especially in the year 1989 and again 1995 to 97, it made the people migrate from their original place of living for their alternate livelihood because of the drought condition. Drought is being considered as a chronic disaster. It will make people as refugees. We are calling it a scientific terminology is climate refugees is nothing but the climate change related impact like drought or the sea level rise and a shoreline erosion. It will make the people migrate from their original place of living. And we used to call them as climate refugees. So this was the drought scenario in Tamil Nadu. And you see that I'm showing the field picture that we have taken in the picture of mangroves. And if there is no sufficient discharge of fresh water coming into the ecosystem, how that the natural felling is taking place. And once that the area started receiving the fresh water, the natural regeneration will take place. So this is the unique thing we observe. Okay, all our interest is how to restore this kind of degradation sites, especially the mangroves. Since the mangrove ecosystem having lot of benefits to the coastal communities, and it acts as a protective measures with reference to natural calamities like tsunami and storm surges, and 1996, and the many of you might have heard about this institution, that is Dr. M.S. Swaminathan Research Institution. I was working in that institution as a senior scientific officer during that time, 1996-98. Especially Dr. M.S. Swaminathan included me in the team of scientists to prepare the atlas, mangrove atlas for the entire east coast of India under the India-Canada Environment Facility funded national program. That program was closely associated with the State Forest Department. So when we are going to make an assessment of mangrove forests all along the entire east coast, each state, what is the total area of mangroves available, what is the present condition. And we extensively use the remote sensing data to see the condition of the mangrove forest. We surprised to see that certain conditions, especially I'm showing here three pictures. One is pertaining to the Kakinada mangroves in Andhra Pradesh. And this is the red color area is nothing but the mangrove forest. When come to the middle one, this is the batch of mangroves in the Mahanadi Delta in Orissa. And this is the national park area, comes under the forest department. And while we are looking into this image, satellite imagery, we observed that within the reserve forest, red color, that area, mangroves, very luxuriant growth of mangroves. Inside the mangroves, red color, we can see that the kind of batches, blue and dark batches. And you look into the pattern of this patch is somewhat regular pattern. And we tried to go to the field, and we actually went to the field, but we are not in a position to enter into this ecosystem to verify what is the real ground reality situation. And this particular area is having another issue of the plenty of saltwater crocodiles will be available. We cannot easily walk into this water body. And that is the reason we couldn't exactly go inside the forest and to verify, but we understood that large hectares and hectares of this mangrove forest was converted for aquaculture. This is purely of illegal activity that happened. That is clearly observed, we can observe using the satellite imagery. This is the one important thing. So this triggered some kind of what is that impact in the state forest department officials, and they understand the importance of the satellite technology. You see that now the satellite technology came to the level, even the judiciary is depending on this technology to understand when this particular building was constructed, when the land area is prepared for the construction, when the first floor of the building was completed, everything closely monitored using the satellite technology. And this is the important highlight about the importance of this technology. Right, and I'm showing that this is another interesting thing. The coastal area where the mangroves were there, the larger batch of coastal mangrove area was converted for aquaculture, that is prawn farming activities along the Orissa, that can also be monitored using the remote sensing imagery. So this is the way we extensively used this remote sensing technology to understand what is the total area of mangroves in the country, what is its condition, and how much degradation site, how to move towards the restoration of this particular ecosystem. The concept introduced by Dr. M.S. Swaminathan during that time is joint mangrove management. It is something similar to joint forest management. The joint forest management was successful in our country because it involves all the stakeholders. It is a bottom-up approach. So the similar approach was proposed by Dr. M.S. Swaminathan for the India-Canada Environment Facility Program. And under this program, this is the important highlights about the giant mangrove management. And see that we need to understand this ecosystem using the scientific methods. And then we have to move towards the training and capacity building and create awareness among the stakeholders on the importance of the mangrove ecosystem. And we have to strengthen the community participation. Community participation is very much required. As social work scholars, you will be knowing more importance of this community participation. And we also need this international funding and to take up this kind of national level program. And this cannot be carried out by a single institution. We need the multi-institutional cooperation and collaboration, especially when we take up this kind of challenging tasks in the national level. Even for conducting a webinar, we used to collaborate. 3 or 4 institution experts are collaborating and conducting 2 days and 3 days even. So think about that when we go for this large-scale national level program. It definitely involves institutional cooperation and collaboration nationally, internationally. And we have to establish linkage with the other community development project. So you see that when you look for that restoration of mangrove ecosystem, for example, sir, we are aiming to restore the ecosystem in Pechavaram, but we need to understand what are the already existing field-based projects that is undergoing in that particular area, how to make use of those projects for this particular purpose, and how to retrieve the degradation site through artificial regeneration measures. So these are the methods adopted by the M.S. Swaminathan Research Foundation during that time, especially towards the restoration of the mangrove ecosystem. And we prepared the very scientific database using the spatial information technology tool. This is the way we organize the data, scientific data. And that data we effectively used, integrated and interpreted in a different way to pinpoint where that ecosystem undergoing the degradation. How much area Okay, right. So what I'm showing this, you see that using the spatial information technology, this is another important technology where we can do a lot of integration of data and overlaying data over another. And we can do a lot of quantitative analysis using this. This is the way we identify where that ecosystem undergoing degradation. And after introducing this kind of restoration process, that is recovering the degradation site through artificial regeneration method and as well as the natural regeneration, how this field-based project is having impact, that can also be monitored. And that is the picture I am showing that what was the condition in 1987, 1971 and 87 and 98. So how much the degradation site we restored and how much there is an increase in the aquaculture area, as well as we can do the very close monitoring of area. The another important advantage of this geographical information technology is whatever that the table of data, field data you have on different parameters like the water quality parameters and all these things, those table of data, non-spatial data, we can convert into spatial form, map form, that we can integrate. I'm giving just an example that one particular water quality parameter, the pH of the water in the collected from the different location in the Pechavaram, that data we converted in the map form. So this is the another important advantage of this technology. So what we achieved finally, really of about a decade of extensive work in the field by various organizations and like MS Swaminathan Research Foundation, the Forest Department, and also some other NGOs, they contributed towards the restoration of this ecosystem. When you look into this Pichavaram mangrove area through your Google map, right, you can see this kind of fishbone pattern. That means they made canals. This is the main canal. There are tributary canals, right? They allowed the fresh water freely entering into the degradation site so that both artificial regeneration can be done in the degradation site and restored back. So through this kind of measures, more than 90% of this mangrove sites were restored back. This is a very, very interesting standing example of restoration of coastal ecosystem in the country. And one can appreciate this importance of this technology tools, remote sensing. Similarly, we have another important ecosystem called the coral reefs. Look this satellite imagery of Andaman Nicobar Island. I am showing a part of South Andaman and the western coast of South Andaman, and it has a very dense rainforest that appears in the dark red color. And then the adjacent, the coastal areas, there is a white line, there is nothing but a beach, and surrounded by there is a light blue color. There is almost turquoise blue color area. There is nothing but the coral reefs. Andaman is also having a tourist spot that is called Vandur National Park. It is a very, very important tourist site where you can go and witness this ecosystem, mangroves and coral reefs together in this particular area. And you can also, when you use this kind of fiberglass boat, when you travel in this Vandur National Marine Park, we can see that the beauty of the coral reefs, live reefs, even we can small islets of reefs available in the Andaman. So this can be easily studied using the satellite imagery. And what we observed when we do a lot of studies on the Andaman Nicobar Islands, especially to map and monitor the land use, land cover, and the coral reefs, mangroves, and everything. See that the Andaman is having a different kind of type of environmental issues. The majority of the population migrating from the mainland to the island, they are settling in the valley plain area. The valley plain area, they are converting this area for agriculture. That can you can very well see in the satellite imagery. I am just moving the cursor. The white color shows the valley plain area where people doing a lot of agriculture activities. And you can see that the entire island, over the surface of the island, when you look from the sky, you can see the skies on the island surface. So it's nothing but the area the people removed and using them for agriculture activities. And you see that mangrove areas using in this manner for the transportation purpose and other things. Okay. And people, again, the 2004 Indian Ocean tsunami has given a very good lesson to the different stakeholders to realize about this importance of this mangroves and coral reefs, how this is acting as a natural barrier. I'm just showing one example, the impact of this 2004 Indian Ocean tsunami in the island groups. And especially the Nicobar group of island is almost a flat terrain. The tsunami water entered one side and came out on the other side. You can see that there is one beautiful island, the Nicobar group. There is a trinket island. And the left-hand side picture shows that the before tsunami and after tsunami. The after tsunami, the impact of tsunami, the island is almost made into three pieces. The tsunami has split this island into three pieces. And though this island is densely surrounded by the coral reefs. Imagine that if this ecosystem is not available, what would have happened to this island? And we also carried out survey immediately after the 2004 tsunami. The Department of Science and Technology given us a project to carry out, make an assessment of the tsunami along the Chennai coast as well as the Andaman Nicobar groups. So we went to the Andaman, but some of the areas we wouldn't visit immediately after the tsunami, but certain areas we are able to manage to visit and see the conditions. And this picture shows that is one place called Mayabandar in Andaman group, where this is the mangroves forcing in the front eastern part of this island, eastern coastal area. There is no single leaves in the mangroves after the tsunami. So the tsunami destroyed the mangrove ecosystem that much, and the considerable amount of population, the people are living just adjacent to this ecosystem. There are the hamlets, fishermen hamlets. And people realized that if this ecosystem was not there at that time, what would have happened to the people living on the coastal boundary? So we have seen this real damage of this, especially the Andaman Nicobar group. These are all the tourist hotels. There is no activities. The tourist department reception desk is one of the important islands. And this was the scenario in the Andaman Nicobar groups. And we are actually comparing the scenario before 2020. Yes, yes. Okay. Before Indian Ocean tsunami and after Indian Ocean tsunami. Okay, so a lot of realization came among the stakeholders. And that is the reason behind we started thinking about the Ministry of Environment and Forest introduced the coastal regulation zone. And that was not successful initially, but after so many amendments, and again the ministry introduced in the year 2011, and which includes all the important aspects, scientific aspects, especially the disaster risk reduction components, and how to make this coastal regulation 2011 is more effective. And also the ministry established the National Center for Coastal Management, and that is in the Anna University campus. And as far as the tsunami is concerned, the country is prepared our own warning system. The tsunami warning system is already available, and in the event of any future tsunami, the people will be getting the warning message. And what I want to highlight about this, the coastal management with reference to the restoration of the coastal ecosystem. So dearly, the joint mangrove management approach helped to restore the mangrove ecosystem. You can, in this national program, used all the important aspects of scientific method, like the usage of satellite remote sensing data, and the usage of the spatial information technology tools, and they use the technology scientific data as a decision support system that will help the decision maker to take an appropriate decision where this ecosystem undergoing the degradation, how to manage all these things. So those kind of national programs is given really help to restore. You see that the same mangrove batch in the Mahanadi Delta, there are so much area was mangrove was removed for the illegal activities. It's restored back in the year 2002. You can see that there is a considerable, this area is really considerably reduced. They restored back the degradation site. So these are all the importance of this kind of national program and the importance of this kind of technology tool, how to closely monitor this ecosystem. And similarly, for the mangrove, the coral reefs, as I mentioned, the coral reefs are also acting as a natural barrier. And if suppose if we are all looking for some kind of ornamental fishes, we can expect more such fishes only in the coral reef ecosystem. We have a very good ecosystem in Tamil Nadu, that is our Gulf of Mannar Marine Biosphere Reserve. And here, this picture shows that we also carried out some study on the Lakshadweep Islands to map the coral reefs in these island groups. And we can realize, you can see that, very well see that in the left-hand side picture, I'm showing the picture. The land area of this island is very limited, but the coral reef area surrounded by the island, it is almost 2 to 3 foot larger than the land area of the island. The turquoise blue color is nothing but the reef. It is exposed reef. Even low tide condition, you can walk along this reef area. There is about kilometers you can walk. And the reef occurs up to a depth of about 12 meters inside the water, sea water, can also be mapped, observed through the remote sensing data. The outer boundary, you can see the deep reefs appears in the light blue color. So this is the way we use the remote sensing data to map the coral reef resources in the entire country. And we prepared the decision support system similarly using this geographical information system, and to understand the changes in the coral reef area, where that reef area is getting reduced and what are the causes. If you go to the Gulf of Mannar Islands, many of the islands, the reef area is damaged mainly because of the deposition of the sand over the area. So this is an important reason is being considered as the threat to this coral reefs in the Gulf of Mannar. And sometimes in 2005, after the 2004 Indian Ocean tsunami, I went for a meeting in Bangkok, and where we had a team of scientists discussed and how to take this importance of this remote sensing and other technology tools to the people working in the decision making level, to make them to realize about this coastal ecosystem. One newspaper reporter has given a presentation about the impact of 2004 Indian Ocean tsunami along the Thailand coast. And he showed this picture, the beauty of the coral reefs and the floor of the sea just before the tsunami. But you see that how much the damage happened to this ecosystem after the tsunami. So this is a way the ecosystem tolerate and manage during this kind of natural calamity. And unfortunately, what happened when we are doing the coral reef mapping in Tamil Nadu coast, when we went for validation of those maps, and certain areas we also found out that this is sometimes in 1998, 97, 98, when we went for this kind of validation of maps, observed that some of the areas that illegal mining of the coral reef still happening, and people are using those mined reefs for this live industries to get the income. That is also what is it? Illegal way of using this resource for their livelihood. And overall, why this kind of impact is happening? And this is some kind of conceptual pictures I am showing. You can look into this land part, the land use, extensive land use. The land cover is getting reduced, the land use area is getting increased, and due to that drought and other kind of natural hazards, disaster, what is happening, and people depending on this agriculture and other activities, they started looking for alternate, and then they started moving towards the coastal areas. And already the coastal areas housing large number of population, and in addition to this, lot of industrial activities that is also happening on the coast. And apart from urbanization and other thing, it leads to pollution, and that ultimately the coastal ecosystem undergoing the degradation. Is just conceptually to understand the ecosystem degradation, what are the root causes. And I already mentioned that the importance of this the rivers, freshwater rivers, with reference to the coastal ecosystem like mangroves. The nature has given a setup that the river has to flow, the water has to enter into the sea, so that this mangrove ecosystem can exist. So we are going to convert this freshwater for agriculture, constructing dams and other things. Definitely this ecosystem can expect some kind of threat in the future as well. And this is, I can continue about that pollution aspect and other things. Briefly, I will, due to the shortage of time, I will pause the slides very fast. I will move the slides very fast to highlight only about the salient points. We use this remote sensing technology to both qualitatively and quantitatively study the pollution. You see that satellite imagery shows the bloom of sediments brought by the rivers, this river Krishna and Godavari in Andhra Pradesh, and discharging the sediments into the ocean. All this turquoise blue colors, nothing but the bloom of sediments coming into the ocean. This is the Bhitarkanika river. How this is discharging the sediments into the ocean? This is river Ganges, discharge of sediments. Everything comes into the Bay of Bengal. So these are all the non-point source of pollution is coming somewhere from the upland, and it is being discharged into the sea. And this also can be studied qualitatively as well as quantitatively using the remote sensing data. This one particular picture shows nothing but there was an oil slick happened in the Madras harbor that we used to study the spread of oil slick in the harbor waters. It appears in the red color. This is the oil slick area. That also we can map using the satellite imagery. When you go to the northern part of Chennai, we have the North Chennai thermal power plant. The power plant is located on the coast, and even majority of the power plant located on the coast because they need to take seawater for the cooling purpose, and after that they can discharge the fly ash, the burnt coal that ash they used to discharge into the sea. In North Chennai, what is happening? The fly ash they are mixing with the water, they are discharging in the form of slurry. This is the discharge point that fly ash discharge. The slurry is going to a distance of about 5.5 kilometers inside the Bay of Bengal, and how extent it is the pollution is going inside the sea, that can be very clearly seen in this satellite imagery on the left hand side. The right hand side, I am showing the picture where how that the thermal plant is discharging the slurry in the mixing with the water. Okay, and we go to the Tuticorin harbor. There they are dumping the fly ash inside the harbor area and making a new area land available, make land availability for harbor activities. There is another type of situation in the Tuticorin harbor. And sometimes in 1990s, jointly with the Space Application Center in Ahmedabad, we carried out a joint study and how to quantify the pollution in the seawater using the satellite technology by collecting the water samples in near real time. That is, the satellite crossing over that area, we have to go to the field and collect the water samples and identify what is the quantity of suspended particles in the water and correlate with the reflectance values of the satellite data, quantify. This quantitative model is also available for this kind of pollution study. Similarly, we are also using the remote sensing data to closely monitor the boundary of the shoreline, how it is oscillating. The shoreline is a very dynamic phenomenon. It is not a fixed one. It used to oscillate. And how the impact of human activities on the shoreline. That is another interesting study we carried out, and we mapped that shoreline and where that shoreline is undergoing erosion degradation. This is one interesting scenario picture I am showing that in our Chennai coast, after the construction of the harbor, the southern part of the coast where we have the Marina Beach, which is extending every year due to the deposition of the sand brought by the sea currents, which is eroded on the northern part, being deposited on the southern part. In the northern part, where we have about 15 fishermen hamlets, that area is undergoing the erosion. That's nothing but in the Bay of Bengal, the sea current pattern is north to south about 8 months during the year. So if there is any obstruction in the flow of sea current, it will hit on one part and erode and bring the material and deposit it on the another part. So this is the way our Marina Beach is beautifully developed. But the other important demerits of this kind of erosion and deposition, you see that mouth part of Kuam and Adayar will be getting closed almost every summertime because of this kind of deposition of the sand material, and erosion is happening on the northern part. Anyone travel along the northern part of our Chennai coast, you can visibly see that how the shoreline erosion is very severe. This picture I have taken sometimes in 1995 December. The temple is about to go inside the sea because of the erosion. Okay, and there are many fishermen hamlets was swallowed by the sea. And this is another interesting example for the Pondicherry coast. The Pondicherry coastline was almost a straight line in 1991 time. After the construction of Pondicherry harbor, again that coastline become almost zigzag in a period of about 10 years. That we can study very closely. This is the situation in many of the villages along the Pondicherry coast. And this building is about to go inside the sea. The seawater came and eroded the bottom of this building. So this is the scenario. This is being considered as another important chronic disaster, and making the people move out of their original place of living. So making them as a climate refugees because of the climate change, the increase in the sea level, it aggravates the coastal erosion process and making the people move out of their original place of living and making them climate refugees. Okay, likewise, the technology is being used extensively, and the ministry also introduced the regulatory measures, Coastal Regulation Zone Act in the year 91 and modified and reintroduced in the year 2011. And they changed the approach, the ministry changed the approach. That is actually originally the DRS is a top-down approach that without including many of the scientific aspects. So that was the main reason for not successfully implementing the DRS in the field. And again, the ministry reintroduced by incorporating various measures, including the disaster aspect and all other important scientific aspects in the coastal management. And now we have witnessed with that restoration of some of the ecosystem like mangroves and the coral reefs, and how effectively we can use this technology. And we are all working towards the integrated coastal zone management by involving all the stakeholders, right? So this is a conceptual diagram how that India, we are working on this integrated coastal zone management. The land use, land cover is taking place on the coastal part, land part, and the pollution is very severe on the ocean part. And many stakeholders, government is working on one side and the community living on the other side. Many non-governmental organizations, they are working on one side, research institution. Make all the stakeholders coming together and to address this issue, integrated coastal zone management. This is the concept, and this is working very well. If we are very particular about understanding the complexity of coastal management and what are the things we achieved in the country, we have documented all our research results in different forms, especially as books. These books are available online. One can Google it and find out. If you're very particular, we can get a lot of information on this importance of coastal management. This is the recent publication, coastal management book released in the year 2020 March. Okay. I think with this, I wind up my session. I think I exactly completed the session in time. All right. Now it is open for discussion. If you have any queries, you can ask me.
Thank you, sir. That was a really very good presentation.
Okay.
Thank you, sir.
This is the way
Can we open it for a few questions, sir? The floor is open for questions. We can take 2 to 3 questions on the presentation of Dr. Krishnamurthy.
Otherwise, I think we have question and answer session at the end.
Sir, your presentation was really very power-packed.
Okay.
Some of them might leave in between, so we thought we'll just go ahead with a few questions.
Okay.
If no questions, then we can move ahead with the. I hope Dr. Ramesh is available.
Okay.
Dr. Ramesh? Yes.
Good morning.
Thank you, sir.
Okay.
And thank you, sir, for sharing your profound knowledge on coastal management and ecosystem.
Thank
Your
you, sir.
presentation was marvelous.
Thank you, sir. I am Bhagyalakshmi. Nice speak, sir.
Valuable information, sir. Thank you very much, sir.
Okay. Thank you. Thank you.
Now we have I call upon Mr. Vishal of 3rd BSc CS to present the poster.
Good morning, everybody. I'm Vishal from 3rd BSc Computer Science from Nazareth College of Arts and Science. I wishing you all a happy World Earth Day, ma'am. I'm going to present about poster about Earth conversion to nature. Common sparrows are going extinct because of mindless urbanization. The current generation is so much surrounded by technology that they have forgotten about nature. The indifference caused by a lack of emotional connect has pushed these birds to the edge of extinction. Earthworms offer many benefits: increased nutrient availability, better drainage, and a more stable soil structure, all of which help improve farm productivity. Water, the most precious commodity, is being abused to such an extent that there is fear that this might lead to another world war, or it may be difficult even to get drinking water. Water is indeed an integral part of human body, as it accounts for 66% of it. The only liquid that quenches thirst satisfactorily is water, and mere 2% dehydration reduces performance by 20%. The only liquid that quenches thirst satisfactorily is water. We can get oxygen from water. This is possible using a process known as electrolysis, which involves running a current through a water sample containing some soluble electrolyte. This breaks down the water into oxygen and hydrogen, which are released separately at the two electrodes. Thank you for listening.
Thank you, Mr. Vishal.
Let's
Now
all come
I
together
request as Devi
and
Manu to introduce our chief guest, next guest speaker.
Good morning, ma'am. Can you hear me, ma'am? Ma'am, can you hear
Yes,
me?
yes, I can hear
Yeah,
you. Kindly be a little bit loud.
yeah. Good morning, ma'am. I introduce Dr. Ramesh. Dr. Ramesh completed his MSc in Zoology from Presidency College, University of Madras, Tamil Nadu. In August 2007, he joined the Salem Eye Center of
I'm
Pathology
sorry
and
to
Natural
interrupt.
History.
Sorry to interrupt. I think you picked up a wrong introduction. Let me introduce myself, okay? I think you guys have picked a wrong
Sorry,
introduction.
sir.
No issue. I'll introduce myself.
Yeah, okay,
You
sir.
can go on to it. Okay. So I think it's probably we should. There's a confusion when we have two Ramesh in the same institution. So I can understand from you. So if without if there's everything's fine, Principal Ma'am, can I just start, or you want me to just wait for some more time?
So please go ahead, sir. Please go ahead. Thank you so much for understanding.
Okay, no problem.
We would want you to come on screen.
No issue.
We would like to see you.
Yeah, no issue. Good morning, everyone. So this is Ramesh from Wildlife Institute of India. So my study started in ABC College in Mailadurai. That's where I did my master's. Then I did my PhD at the Wildlife Institute of India, and also along with the Forest Research Institute. In fact, I have some of my friends who studied with me are also attending this meeting. I can see that. And I mean, I know when I was contacted by the principal, we could actually understand, okay, this is an important event. So that is why I was also very happy to connect, because this particular topic is a very, very important one. both from a local as well as international context. So my work has mostly been in the Himalayas, initially doing work on pheasants and also involving a little bit of remote sensing. Then I worked in northern part and central India. So mostly my work has been on looking at the landscape, species, restoration. So today the talk that I'll be having is to kind of highlight the large predator. I was very pleased to hear this entire presentation by the Professor Krishnamurthy about the remotes and GIS. I think that's kind of set the tone for the day, because without habitat, nothing is possible. I think he's been able to highlight using remote sensing, although a lot of emphasis was on obviously on the remote sensing per se. If somebody looks at the content of it and the details of it, it really tells us what's the current state of affairs is. We've been losing kind of what I say, habitats after habitat, and even important areas have been lost. So that is why I think I wanted to take it from there. He's also kind of highlighted a very specific habitat like mangroves and very important ones. So unfortunately, we are all not paying attention to even this poster when the boy presented. It's very nice to hear such a clear understanding or emotional connect to nature. But it's also time for us to reflect, because nature conservation also means it's not left to one particular department. I mean, that is the reason that even your college is celebrating, because nature has actually the benefit for everyone. So therefore, there's also the need for commitment from everyone. So from that perspective, I would like to begin this talk saying that how restoring a nature. I mean, it's probably very difficult. We cannot possibly restore a nature as it is. But then there are certain things that we can obviously do. So that is what we can highlight, how some of the aspects that we have been doing, how it can bring back. Is my slide visible? Anybody can confirm?
Yes, sir, it's visible.
Yes, sir.
And is it moving also? Because sometimes it doesn't move. Is it is going next slide?
Yes, it's moving, sir. Yes, it's moving, sir.
Thank you. So when I said restoring a normalcy through large, I think that was a fantastic topic suggested by your principal. I think I would owe the topic to her, although I added the large predator myself. I think that was a nice topic to go with. So as I said, I currently work with the Wildlife Institute of India, which is an autonomous institution under the Ministry of Environment, Forest and Government of India. So I also work with, University of British Columbia, the Faculty of Forestry, where we've been doing a lot of collaboration. So mostly to do with the forestry and conservation science. So large predator, when we say, as far as Indians are concerned, I think tiger should be the species that should come to our mind, because that's our iconic species. It's found all over the country. But if you look at restoration per se, this is the global scenario. You can see this map and understand for yourself. All over the world, people have been looking at restoration as an important measure to restore, I would say, restoration of habitat or species. Although most of the reintroduction has happened more from the species perspective, obviously species doesn't exist without habitat. So any restoration means you're restoring habitat. That's a key point that we need to remember. Habitat conservation is a fundamental to everything. Without habitat, no species exists. Without species, all those linkages that we're talking about doesn't exist. I think it's an important reminder to us for the last 1 year, this pandemic like COVID-19 is actually telling us how we have badly treated the nature, and the nature has come back to us in the form of a virus. So some of the solution to this is maybe currently we put in a vaccine and all that. These are only a temporary solution. If you really wanted to ensure the sustainable development both for human and the nature, we need to start respecting nature. And respecting does not mean just simply appreciating it or worshipping it. Get into some action. The action also does not mean that you become a active conservationist or a forester, but certain things that we can do within ourselves. I mean, being able to kind of not getting involved in destructions or use of resources in a very limited manner, not showing extravagant lifestyle. I think there's small steps that each one of us can take it. But unfortunately, I mean, these things are not percolating to everyone, and we are losing a species like anything. Coming straight to the topic, restoring the normalcy through large predator. This is a very important, very interesting paper that I read in this is an article written by Katharina. She basically started asking this question: can rewilding large predator regenerate ecosystem? Okay, because this is what we've been talking about. A large carnivore reintroduction means it can restore the system. But then how to go about it? I mean, what exactly happens is what we need to really understand. So this is the one classic example. This picture, if you can see, I mean, it's again coming from this particular article in Scientist. Cascade Effect. So very famous, very famous example from Yellowstone National Park in the US. So whenever we talk about any studies on umbrella species, cascade effect. So cascade effect means that if you remove one particular species, it basically gives an impacts on multiple species which depend on them. It's like if you have a bunch of cards, when just to snatch it one, then the whole of them falls apart, something like that. So I think natural system per se, I mean, if it is arranged in a very structured manner, in a very nice hierarchy, so any of those, the hierarchical system is disturbed, it can have an impact. But if you remove the top order predator, which is structuring the whole ecosystem in the form of a pyramid, I think it can cause cascading effect. So Yellowstone National Park example is more for the wolf. So when the wolf was hunted down, they could see a spurt in herbivore population. The spurt in herbivore population started putting pressure on the regenerating vegetation. So regeneration vegetation means particularly along the river banks, and then the water body is getting dried up. So there's a kind of cyclic thing, even though there are a lot of controversies about this example, but by and large, this has been accepted as a cascade effect illustration. So we all know, I mean, it's because cascade effect is not just a small event. It takes a long time. It's very difficult for people just picturize and demonstrate it. Therefore, these uncertainties will always be there. But just for viewers, I think this is something that you might want to remember. The cascade effect example mostly comes from this Yellowstone example of wolf removal and its reintroduction. So reintroduction also took place, which resulted in restoration of habitat. That's what the scientists have documented. There's nice videos also available on YouTube. If you go to YouTube and see large predator and water, you will be able to see a very nice video. So this is the data about this. So the cascade effect, the famous Yellowstone event. So wolf, elk, and the vegetation regeneration, you can see this graph. So when the wolf was present, the natural system was maintained as a normal equilibrium. It's like a normal distribution. So higher, sort of some old growth, some young growth, and things like that. And it's an example for both aspen as well as cottonwood. But when the wolf was absent, there was a lot of reduction on this vegetation. So you might want to ask why, or how is it basically wolf and vegetation connected? So the missing link here is this elk and moose. In the absence of any large predator, it is very much natural to expect that the herbivore population will flourish like anything, probably in an exponential growth. So that puts pressure on the vegetation regeneration. So that is how the growth pattern has been suppressed. When the wolf was reintroduced back in early 70s, this is again almost, we're talking about 30-40 years now. So they've been able to see the differences in terms of regenerating growth, because there's again a control on the predator. That is why they say the restoring a system through a predator can work, because predator by and large structures the whole ecosystem. In what form it structures, to what time it is structured, these are some of the things that we really need to understand. So this is what one of the quote I picked up from the same article is that the predators are so important. The removal has such long-lasting effects. The predators are so important. The removal has such long-lasting efforts that it is naive to think that you can quickly reverse the effects of their absence by restoration. That's related to what I said previously. it may be possible for us to understand, okay, predators have an effect, predators have linkages. You can bring back predator. When you bring back the predator, it's not possible for us to appreciate quickly that it will bring the entire ecosystem back. It can only approximate it. You can take it for granted. Any system that is changed, whether if you cut a tree, there is planting a tree or replanting a tree, it is not exactly the same. So it's important for us, first of all, recognize anyone does any destruction on the earth, even just trampling on this grass or just removing some bird from here to there. Even if you do some restoration measures like wetland restoration or regenerating growth, it may only approximate. It cannot be exactly the same. So the first choice should always be not to destroy. In the unfortunate situation, we do it very often for the development, for other purposes, sometimes totally out of ignorance. When we do all this, so even when we make the best effort to restore, you please understand they are not exactly the same, because one cannot reverse the system as it was, because whatever happened is not just a short-term event. It is done over millions of years, over different interactions with multiple players in the system, both biotic and abiotic. So if you really needed to have any restoration, it needs to be kind of understood that we are not actually doing exact same, but then we are doing the next best possible thing, which is also very, very important. So from that context, I wanted to pick this quote specifically because even many of us do think that, okay, when I'm just doing a restoration of this, bringing habitat back or bringing a species back, we're basically doing whatever that exists in the past. May not be exactly the same. To say that it is the same, it probably requires long-term observation. So I think there are a lot of examples in the US also. I mean, before I come to Indian example, I'll talk about cougar is another example where some of the predator, like in India, we have tiger and lion, but in Western countries, the large predators, mostly the cougar. An important linkage is also to see this presence of scavengers. In the absence of large predators, you do not have scavengers. If you don't have scavengers, the systems are not maintained. Quality, we're talking about human health. All these are linked. So scavengers are very important role as much as the predators. So you can possibly maintain certain population control measure and things like that, even for the short term in the absence of say large predator, but you cannot, as I said, recreate exactly the same system. The scavenger becomes a very important example. So you can always relate this. Look at many tiger reserves in India. So the vulture populations come back wherever the tiger populations, its number is increased. So these linkages have to be thought through whenever we talk about restoration. When we talk about bringing normalcy, so it's like normalcy, yes, we're looking at the approximation, but we need to also see there will always be a new normalcy, which need to kind of mimic the historical context. So the other quote, while it's well accepted that large carnivores play a vital ecological role, just how they shape ecosystem isn't well understood. That's again what I said earlier. We have not understood well. So we know this is what's happening, but it's not been understood that well to make very clear statement, oh, you do this, this will happen. You do this, this is not possible. So this again reiterates to our mind that our understanding of nature is not as much as we think we know, because nature has brought in or is structured by much more complex relationships than you and I understand. Therefore, just to kind of decode the relationship of the large predator, herbivore, the system and water and our life is not as simple as it may sound. So therefore, it's best to try and see how much we can preserve, and wherever we are lost, I mean, like the professor who had given an example, like how things have changed. So wherever it's possible, we can try to restore the system, because it's only for human good. I mean, many of the time people are destroying nature in the name of development, or I mean, sometimes it becomes a compulsion. You have no other option, you do it. sometimes you don't have an alternative, or our mind doesn't provide an option to look at an alternative. In such situation, we make a lot of mistakes. But wherever there's an opportunity to bring the system back, I think we must try, whether it is a forest system, whether it's an agriculture system, whether it's a river system, whatever system, even urban system. Even urban system is also, it's not just a building. So urban also, where people are living, we need water, we need clean air and all that. So I think the restoration has to become one of the key aspect in our life. Only then all those issues that we're facing currently, whether it's climate change, whether it's pandemic, it can only be addressed in the long term. Otherwise, we'll be firefighting. The firefighting has a huge cost, both in terms of lives and the money. So in that such a situation, now we have one new species to India. I mean, to the old species, it was lost, the cheetah, the famous cheetah, the fastest land animal on the earth. So we had them. I mean, it's very good looking, and when they are in pack, you can see it's a very beautiful animal. So we had this distribution. You can see this distribution. They were distributed all over the tropical region, except your South America, Africa, mostly in African. I mean, it was, if you look at it, this whole continent, India and Africa together. So it was there all over. You can see this, the light yellow shade is a place approximate. They're actually putting an approximate historical range, which means that people did not have complete knowledge, because the approximate, actually I could pick up this word approximate, because we know there are records in India. Cheetah was supposed to have been found all the way up to Tirunelveli. So currently it is shown up to Karnataka, but then it's not in Tamil Nadu. But yes, cheetah was recorded to be, also found all the way up to Tirunelveli. So the distribution that is shown, the historical distribution, is little less than what exactly it was in the past. But now, look at the current distribution. They've been restricted. In fact, they've been hunted down very badly. Even the population that have come back here in Africa also, it's a kind of come from a small population after huge conservation effort. It's a small population with the conservation supports come. But in Asia, there's only very small population in Iran. So India now wants the cheetah back, but we seem to have a lot of habitat. So now, although this argument for cheetah is that, yes, it's an important predator that we lost, we need to bring them back even as a species. It will make sure that now India is on the top of this conservation kind of steps, or in the framework, the way the global conservation agencies look at each country. But the habitat becomes important. Now currently Gujarat and Rajasthan, some more places, even Tamil Nadu also may have this habitat, but it requires a lot of effort. Suppose if that species comes to India, with a lot of efforts being made. So again, it's more of a challenge now, since we lost much of its original habitat. Because as I said earlier on, restoration of the species essentially means restoring habitat. So it's a good thing to have a species come back and restore habitat. But then we also need to see whether we have enough habitat that you can restore. So if you converted everything into agriculture, bringing them back into natural system, which might take much longer time than what we have. So again, we might be forced to do firefighting or work around the limitations. Coming to India, I think if anybody talks about India, I think the things that they remember is Taj Mahal and tiger. So tiger is surely an iconic species for India. It's a large charismatic predator sitting on the apex of the system. It's a flagship species. It's a both flagship and umbrella. So you might want to wonder what is flagship, umbrella. Flagship species are those one which people can connect. It's very easy to relate. Like peafowl. Peafowl is known by everybody, it's culturally related. So it's a flagship species. Okay, they're like ficus, some of the trees people recognize. These are flagship species. And using a flagship species, people can advance conservation agenda. Umbrella species are the one which basically have a larger range under which several species are surviving. So by protecting that particular species, you are able to protect the entire biodiversity system. Those are ones are called umbrella species. But tiger has got more aesthetic value too. It's an amazing species when you look at it. And it has got clear ecological role and economics. I think tiger-based tourism is huge. $1 million are being earned. A lot of people from both India and abroad visit tiger reserves. And obviously ethics is one of the things that we often talk about. So nature has brought things, and obviously conservation becomes our ethical responsibility since we have made a lot of damage. Again, like cheetah, tiger distribution mostly in the Asian region, and we didn't go to Africa, unlike cheetah. But if you see the historical distribution, they have been everywhere. They've been everywhere, but currently they've been reduced. So currently the estimate says we are only having 6% of the habitat which originally tiger lived in the past. Yeah. So it's something that we need to remember. So although people talk about 6% solution to the whole context, and but then it's a big challenge. So to have tiger survive in 6% of historical habitat means a lot of work that needs to be done. But even in this 6%, India is having about 70% of the global tiger population. In the 70% of global tiger population in India, the region that is located in south, Karnataka, Tamil Nadu, Kerala, that region contiguous to the bordering area, they are having about almost 30 to 40% of tiger population. So the largest population of tiger and elephant are actually located in the Western Ghats part of Karnataka, Tamil Nadu, Kerala. So it's very important to recognize these small details because they have significant value in the national and international context when it comes to these species conservation and the habitat conservation. Because as much as we are happy about or being very proud of these species to be found in our region, it also calls for the huge responsibility to ensure that they continue to survive. So within India, that I think the direct relationship between the tiger habitat and human population, you can see in 18th, 19th century, tiger was distributed almost all over except this, the Eastern Ghats part a little bit. I think that also got eliminated. And then there are gain in some areas, but loss in many areas. But with the current human population of 130 crore people population, you can see that many of the tiger habitats are restricted to a few pockets. So there's central India, there's one Western Ghats, the northeast, and Tarai landscape. So this is how the tigers are distributed. Why tigers are so vulnerable to extinction, like large predator loss? These are the reasons, because tigers have very specialized life history trait. Yeah. So their behavior is such that so they can produce 1 to 5 liters the maximum, but they need to have a regular prey supply and undisturbed habitat. There's constant competition for space, so they need to fight among each other between male and female competition. Human-tiger conflict, when the tiger population is getting into depredation livestock, is a very common case that the livestock is used as a medium to kill tiger. They poison the livestock, kill. And poaching, this is both national or international market where tiger poaching is a very professional endeavor. But tiger conservation in India is beyond species because of the umbrella species effect. So the Project Tiger and followed by the tiger reserve that was established, it enabled tiger population simultaneously helping other species thrive. So it's more of a kind of a large habitat conservation than species conservation, although Project Tiger is said to be a individual species conservation. But if you look at the whole philosophy behind it, it was to ensure habitat conservation as such. So as I said earlier, although the range size is reduced 60%, India has continuously lead the world in terms of number, 70% of the global population we have. So the conservation investment and success have been tremendous from Indian Forest Department and professionals. So I think India has been leading the way from the very beginning. Even today, among the 13 range countries, India has been pioneering tiger conservation efforts in many of the fronts, whether it habitat restoration, species recovery, smart patrolling, you name it, anything related to tiger conservation, we'll have examples from India. But while we talked about tiger conservation being a primary success for India, but India also faced several setbacks. One of the major setbacks, which also kind of an eye-opener for the country's perspective, was tiger extinction in 2 important tiger reserves in the country. One is Sariska Tiger Reserve in Rajasthan. This is here, which is the Rajasthan is marked in the red boundary. Panna Tiger Reserve in Madhya Pradesh, a blue boundary. These 2 places I think, brought the whole situation back in the fore, saying that the status of tiger conservation in India is much less adequate than what one would have thought of, given the conservation history that we have. Because the huge area to deal with, the poverty to deal with, the development to deal with, I think given multiple aspects to consider, forest and wildlife has taken the beating, and these two places have become eye-opener for us. So Panna is located in, say, the Vindhyan Hill Range. It's the core area is about 543, and there's about 1,000 square kilometer buffer area. It's a dry desert element. It is also the place where the teak is the natural limit. The northern limit for the teak is where is in Panna. So it is a dry desert system with it looks like a savanna type. The multiple forest types here. It's a satellite imagery. There's a process satellite imagery tells us several forest types here, as well as land use types. And it is the history of this park is started with the game sanctuary. It was a game sanctuary for the kings, the princely states, and then. So in fact, Panna said to be the donation to the government by those princely states. I mean, whatever, either directly or by the law that time it was enacted. It became national park. Then 1994 it became the tiger reserve. So Madhya Pradesh, many of you may not know, is one of the leading states in the country when it comes to wildlife conservation in general and tiger conservation specifically. They've been proactive with many of the efforts based on which they've been able to excel in many conservation discourse. Panna is a beautiful site. You can see this. It looks different in different season. Dry desert system, you have fall season, you have wet season, and these terrain also, like, because being part of Vindhyan Hill Range, which I think it's more of a volcanic formation, you have a step kind of situation. Steppy, they call it different steps. So there's a plateau, there's an escarpment. So if you come and see this place, the scattered trees, more like a huge savanna, African savanna. Okay, it's a savanna kind of forest you have. So that way, it's a very interesting place. There's a lot of work that has been happening on this tiger reserve. Even one of the long-term study on tigers was done here by one scientist, Dr. Gudnavati, used to work at the Wildlife Institute of India. The Ken River is a perennial river, even though you have a dry spell in between. But because it's an important river, currently this is under the focus for one of the major riverling projects in the country. It will be the first major riverling project, although it's calling a riverling project, but I think it's a dam and then the water being supplied to irrigation and drinking water. And a lot of vultures on these escarpments. So Central India again has a lot of vultures. Several mammalian species. So number of species in a system indicates the kind of habitat it has. So including species like wolf and wild dogs. As I said, the habitat is the key parameter that one needs to look at whether the area is good or bad. So when you're restoring a species means that you're actually trying to contribute so much for a different kind of species. In that context, I think Panna, this is where I've been working for the last 10 years. I've been important case study when it comes to large predator restoration. So this same success has also been done in Sariska, but the kind of number that has been brought in Panna is nowhere comparable to any other sites, because the number is huge and it is said to be one of the fastest large predator recovery in the world. I can tell you, I'll show you as you move along the slide. So we actually were fortunate or unfortunate to be part of this whole exercise from 2008, trying to look at what the tiger population status was. We could kind of document the tiger population was declining. There's a lot of issues. I will not go into those details of what went wrong there. If anybody has any question, they can ask me and then I'll explain. But just to give you a story, this place was one of the tiger reserve, but the population started declining. In the year 2009, the lone male that was photographed in 2006 also got disappeared. We don't know. I think the reason that attributed to poaching and the animal going beyond. This is an overview. So the local extinction happened in 2009. 6 tigers were initially a part of the plan to be translocated. And there's one more animal that came. And phase 1 was considered from 2009 to 2014. Phase 2 was considered 2015 to 2020. So now we are in the winding of phase. So these tigers were brought from different places to restore the population. So you can imagine that Madhya Pradesh has got many tiger reserves. There are options to restore. So multiple individuals came from one set of animal came from Bandhavgarh, Kana, and Pench Tiger Reserve, and one also came from Bhopal. There's a place called Rantampani. So this is how tiger population came. So they were, one of them were translocated by helicopter. Okay, initial of the 3 tigers, one came by helicopter, rest came by road. And these animals were generally radio tagged, which basically means that putting a transmitter around a collar, transmitter sends out the radio frequency or GPS, even unit in it. So from GPS gets uplink to a satellite or from ground station. This is how the animals have been monitored 24/7. These animals, once brought in, they're released in this place called soft release enclosure, which is about 1 hectare area, where they actually made to acclimatize or under medical observation. We also rescued some of the animals which were rescued, also rehabilitated. This is a cub that was rescued at the age of 3 weeks, and they were grown in some of this facility called quarantine facility. Then in a semi-wild condition, finally they were translocated to Panna. So all these animals where combination of wild caught as well as the captive animals became a source for translocation to Panna Tiger Reserve. So we also recorded first success through this litter of 4 cubs. It was in 2010, it was seen. So which basically marked the beginning of the success story when it comes to Panna. Even though there are a lot of challenges, skepticism in the past, these tigers coming back and then producing litter was an important milestone and it's a welcome step. So 4 cubs, all 4 were male, but unfortunately we lost 2 cubs to, we don't know the reason even today, what exactly happened. There are a lot of stories around. But these 2 cubs grew up together with the mother, and the mother is still surviving. So almost, you can imagine, from 2009 to now 2000, she was about 4 to 5 years. Almost 15 years, she's still surviving and producing litter. And these 2 boys grew up well, and it became a dominant animal. So this is the entire story. This particular story that I just showed you, it tells you how the entire predator recovery takes place, because these animals brought to a new system, adapting to a new system, trying to find is the best place, surviving on the predator, basically suggests that this area has its potential. So restoration, see, because tiger translocation, this particular place has happened too quickly before probably the system starts getting affected. So when I said initially, restoration after a long time might be very difficult to revert back, because the tiger population gone extincted within 3-4 years. By the time the predator population had to come up and putting pressure on regeneration, yes, we could see some differences, but it was too short time we could address it. When the department took the initiative with the support of National Tiger Conservation Authority and the Wildlife Institute of India, so the system response to non-normal situation could be averted by quick response. If you don't do a quick response to natural system, then as I said, the restoring to the same normalcy may not happen. But in this case, at least we can assume the response is not so definitive. The direction has not been taken place. So this is probably building up by this translocation. Not only the translocation, the success also enabled. You can see these cubs, this particular animal now is the most dominant tiger there. And even this animal is becoming old. The others are taking over. So the system has come back to kind of normal from the tiger point of view. But from other habit point of view, there are a lot of questions that needs to be answered. And the good thing is that we have a large team looking at different aspects that is documenting these things. So you can see this graph. This graph should tell you the entire story, starting from 2009 to now. And this is a graph that everybody would love to have, because in terms of the population growth, nowhere else you see that large predator growing in this way continuously. There's some year in 2017, we lost a couple of mothers that reintroduced animal, but otherwise the growth has been very constant. and 52 tigers in the park, and say 92 overall produced, which is some of them are translocated elsewhere, some are in the landscape. So the population reached beyond its carrying capacity. So which means that the system has kind of brought to its own state in the tiger conservation, tiger population point of view, and it is still growing. In fact, this number that we currently have is probably the large number of tiger ever recorded in this place, even much before than the original population that we lost. The original population earlier said to be around 30, but now the population is much beyond that. And it's still growing because simultaneously other efforts of habitat consolidation is happening. Now, from the tiger reserves, we are also trying to go to the entire landscape conservation. I think this is where the remote sensing and the modeling approaches, these kind of field approaches will be very beneficial. So we've been looking at this one simultaneously, all these aspects that we need to consider. So this particular graph is something, it's important. And then the tiger reserves and tiger population status. If you look at in Indian context, 1973 is where, I mean, exactly this month in April, the tiger reserve, the Project Tiger was launched from the place called Corbett Tiger Reserve. So during 1973, 9 tiger reserves were established. But today we have 2020, 50, 2021, 51 tiger reserve. The 51 tiger reserve is actually from Tamil Nadu, Megamalai and Srivilliputtur Tiger Reserve. It is actually called SMTR, Srivilliputtur Megamalai Tiger Reserve. So it's 51th Tiger Reserve. So that what exactly it means. From a common man's perspective, it might be 1973 we had about less than 500 tigers, but in 2020 we had more than 3,000 tigers. Okay, so this is how we need to see from the tiger number. But then what we have achieved is not just the tiger number, consolidating the habitat, making sure these reserves remain inviolate, protected forever. So increasing the tiger also means increasing the tiger occupied area. The tiger occupied area means increasing the natural system, the nature to be in a natural state. So I think these are very linked aspects, but when you look at tiger number, please don't just fall for the tiger number and look at how much of the area we have been able to consolidate or protect. So other sites which are actually in the pipeline is to restore tigers are these. So Sanjay tigers in Madhya Pradesh, Sayadri tigers in Maharashtra, Satkosha tigers in Odisha, Mukundra Hills tigers in Rajasthan, Buxa tigers in West Bengal, Rajaji tigers in Uttarakhand. So they will probably add to more than 200 tigers, but then it will also restore 5,000 square kilometer area more. So this relationship between the large predator and the habitat is also going to be useful for many other species, many of the ecosystem services which we all depend on. So whether it's a clean air, water, all other system services that we look for, I think these areas are providing it. See, conservation to me, in a way, is a more of selfish endeavor. If the conservation works, if the nature system is proper, I think our survival is ensured. I mean, it is not like very philosophically we say, nature destroys, but just quality of life. Our quality of life will be largely determined by the way the natural systems around us. So conservation, when you talk about these conservation interventions, IUCN is an organization which is a voluntary organization with several experts all over the world. They come up with different framework. That framework helps us to find out, okay, what needs to be done, what should not be done. So if you look at this particular flow chart, it tells you a conservation situation. Currently, it is applied to everything. You can apply to river system, marine system, mangrove, whatever. What is the current situation? Okay, current situation is either habitat is good or bad, or the population declining, increasing. So first we need to assess the current situation, then decide what you want to do. What is the goal? What exactly we are aiming at? Once the goal is determined, then look at options. Whether in the case of tiger, I want to translocate or not translocate. If I don't want to translocate, then I should know what are the options, whether the animal can come on its own. So the goal, after the goal, you look at an option, then feasibility. Once you decide an alternative, we need to look at feasibility, whether this alternative that I'm looking at is feasible or not. Okay, if it is feasible, then what is the risk? So these two things need to accompany. I think this is also for a business. If for anything that, for that matter, we do, anything that we want to do, this kind of decision-making process will have to follow. Once the alternatives have looked at, feasibility assess, risk assess, then you decide on what to do. Once decision is made, then look at the design. How I should go about doing it. What are the specific action point that I need to look at? After having decided on the design and specific action point, again, you need to look at the feasibility, whether the design and option that I have is good enough, what kind of risk I'll run through. All this needs to be decided. And then look at the implementation. Once all these are ensured, then start going ahead by implementing it. But implementation also needs to accompanied by the monitoring. So you need to actually see what is being implemented and what is the response. Once the response is monitored, then you can look at the outcome. Okay, what exactly the outcomes are. So the outcome you can disseminate if it is successful or bad. At the same time, if there is any lesson, then you bring it back to adaptive management cycle, provide the feedback to whether the system design, or it can also go to the risk, or it can go to the situation. So it's all kind of a loop. So this particular flow chart, I think you can remember, or you can take it from IUCN website, can be applied to any situation, any action that we do. So this is how the restoration should take place. When you talk about normalcy, what exactly are you looking at it? I want to bring this particular habitat to normal. How I should do it? What is my overall goal? What are my options available? Suppose if I want to do a river conservation, what should I do? Should I leave the river as it is, or I need to start repairing if it is required? So these are small questions that we need to ask and then decide on. So just to sum up, I mean, all these things that I gave you, the ideas all started from the place Panna. So in fact, there's a nice book written by Raghuchan Dawat, it's The Rise and Fall of Panna. But I think I would say the fall and rise of Panna, because the intervention period that I got into was in 2009, where this Panna was fallen. I think it is risen to a really good number, which is considered to be one of the big success story when it comes to tiger conservation is concerned, not just in India, around the globe. Panna is a model. It's an inspiration, actually. So as I said, Panna has made a remarkable turnaround from what was lost, and then it's come up as an inspiration, although there are a lot of issues around it. But when it comes to the habitat restoration and then making sure everything, it's a long way to go. So we still continue to working on, it's 10 years now, but conservation cannot be just as a project. You just do it and then go up. It needs to be made as a continuous progress. The leader has to be the forest department, and they've been, wherever they've been owning conservation, things are working really well. So conservation is, as I said earlier on, is a collective responsibility because it has got collective benefit. Forest department may be the custodian in the context of administration and then investment, but I think that a lot of NGOs and the individuals, others are also involved. So conservation has a kind of a collective response. We need to recognize that accordingly. So thank you so much. I think I within an hour and time for discussion and question. Do I can also answer. Thank you so much.
Thank you very much, sir, for sharing your profound knowledge on extinct animals and tiger reserves and population data. The session was very informative and knowledgeable, sir. Thank you very much, sir.
Thank you.
Now we have poster presentation. I call upon Mr. Deepak of second year BCA to present a poster.
Hello. Good afternoon.
Yes.
Good afternoon, everyone. This is Deepak, second BCA in Untitled College of Arts and Science, and I am here to talk about our planet power source in this 2021 Earth Day. In recent years, coal and nuclear energy is most used power source in produce electricity, and also the most pollution produced source made by humans. Since humans born beyond depend Earth source, but modern centuries, humans are made with more power sources. Can you guess the major source of nature? Yeah, it's forest. Look at the pie chart. You can recognize what I trying to explain. Now come to the major topic of power source. Yes. நம்ம இந்த மாடர்ன் டேஸ்ல பார்க்கும்போது பார்த்தீங்கன்னா நியூக்ளியர்ஸும் கோல்ஸும் தான் மேஜர் சோர்ஸாக இருக்கு. ஆனால் வந்து இது ரொம்ப பொல்யூஷனேட்டிக்காகவும் ரொம்ப ஆபத்து விளைவிக்கக்கூடியதாகவும் இருக்கு. பட் அப்படி பார்த்தோம் அப்படின்னா நம்மளுக்கு பவர் சோர்ஸ்க்கு என்ன ஆல்டர்னேட்டிவ் இருக்கு அப்படின்னு நம்ம பார்க்கணும். அப்படி நம்ம பவர் சோர்ஸ்க்கு என்ன ஆல்டர்னேட்டிவ் இருக்குன்னு பார்க்கும்போது சோலார் எனர்ஜி, லைட்னிங் எனர்ஜி அண்ட் ஹைப்பர் எலக்ட்ரானிக் பவர் எனர்ஜி, இந்த மாதிரி நம்மளுக்கு 3 எனர்ஜிக்கு இருக்கு. நாங்க 3 மேப் உங்களுக்கு இது ஃபிகர் அவுட் பண்ணியிருக்கேன். அந்த 3 மேப்பை உங்களுக்கு நீங்க ரெப்ரசென்ட் பண்ணி பார்க்கும்போது உங்களுக்கு நான் என்ன சொல்ல வரேன்றது புரியும். ஃபர்ஸ்ட் மேப்ல பாத்தீங்கன்னா சோலார் பவர் எனர்ஜிக்கு, அந்த சோலார் பவர் எனர்ஜிக்கு தேவையான சக்தி நம்மளுக்கு இப்போ சோர்ஸ் எங்க கிடைக்குன்றத அந்த மேப்ல ஃபிகர் அவுட் பண்ணியிருக்கேன். ரெண்டாவது சோர்ஸ்ல பாத்தீங்கன்னா அந்த ப்ளூ கலர் ஏரியாஸ் பாத்தீங்கன்னா நம்மளுக்கு வாட்டர் சோர்ஸை நம்மளுக்கு ரெப்ரசென்ட் பண்ணுது. அதே மாதிரி தேர்ட் மேப் கீழே நம்ம தேர்ட் மேப்பை பார்க்கும்போது நம்மளுக்கு விண்ட் சோர்ஸ் நம்மளுக்கு எங்க கிடைக்குதோ அது நம்மளுக்கு ரெப்ரசென்ட் பண்ணுது. ஓகே, ஃபர்ஸ்ட் ஆஃப் ஆல் ஒரு இப்போ இன்ட்ரெஸ்டிங்கான ஒரு ஃபேக்ட் ஒன்று சொல்றேன். நம்ம பூமியில நம்ம இந்த எர்த் பிளானட்ல 1 மினிட்ல நம்ம சன்ஷைன் 1 மினிட்ல இந்த வேர்ல்ட் ஃபுல்லா இந்த எர்த் ஃபுல்லா பவர் காட்டுற சன்லைட்டை வச்சு மட்டுமே நம்மளால இந்த வேர்ல்டுக்கு 7 மினிட்ஸ் கரண்ட் நம்மளால ப்ரொடியூஸ் பண்ண முடியும். இது ஒரு இன்ட்ரெஸ்டிங்கான ஃபேக்ட். ரெண்டாவது ஃபேக்ட் என்னன்னு பார்க்கும்போது ஒரே ஒரு பவர்ஃபுல் தண்டர் போல்ட்டால கிட்டத்தட்ட 7 நாளைக்கு இந்த உலகத்துக்கே நம்மளால பவர் ப்ரொடியூஸ் கொடுக்க முடியும். இது ஒரு இன்ட்ரெஸ்டிங்கான ஃபேக்ட் இல்லையா? ரெண்டாவது பார்க்கும்போது ஒரு ரிசர்ச் படி பார்க்கும்போது 2035ல கிட்டத்தட்ட 90% ஆஃப் பவர் கன்சப்ஷனை நம்மளால ஹைப்பர் எலக்ட்ரானிக் பவர் சோர்ஸ் மூலமா கொண்டு வர முடியும்ன்றதை ரிசர்ச் மூலமா கண்டுபிடிச்சிருக்காங்க. ஹைப்பர் எலக்ட்ரானிக் பவர் சோர்ஸ்னா ஒண்ணுமே இல்லை, நம்ம வாட்டர் கனல்ஸ்ல இருந்து நம்மளுக்கு கிடைக்கிற பவர் சோர்ஸ் தான் அது. ஓகே, இன்னொரு இன்ட்ரெஸ்டிங்கான ஒரு ஃபேக்ட் சொல்றேன். நம்ம வாஷிங் மிஷின் எடுத்துக்கோங்க. நம்ம இந்த சோர்ஸ்லாம் பார்க்கும்போது நம்மளும் இந்த சோர்ஸ்ல நம்மளால ஒரு பங்கை நம்மளால கொடுக்க முடியும். அது எப்படின்னு பார்த்தோம்னா வாஷிங் மிஷின் இருக்கு, ஓகேவா? கிட்டத்தட்ட வாஷிங் மிஷினோட 90% ஆஃப் சோர்ஸ் எதுக்காக போகுது அப்படின்னா அந்த வாட்டரை ஹீட் பண்றதுக்கு மட்டுமே போகுது. ஓகே, நான் என்ன சொல்ல வரேன்னு புரிஞ்சுக்கோங்க. அந்த இதை ஜூம் பண்ணி பார்த்தீங்கன்னா உங்களுக்கு புரியும். கிட்டத்தட்ட 90% ஆஃப் எலக்ட்ரிசிட்டி அந்த வாட்டரை ஹீட் பண்றதுக்கு மட்டுமே போகுது. இதை நம்ம எப்படி தடுக்க முடியும் அப்படின்னா கோல்ட் வாட்டர் நம்ம யூஸ் பண்றது மூலமா ஒரு பவர் நம்ம 90% ஆஃப் பவரை நம்மளால சேவ் பண்ண முடியும். அண்ட் தென் கிளாத்ஸுக்குமே இது ரொம்ப ஏற்றதாகவே இருக்கும். இந்த மாதிரி நம்மளால கொஞ்சம் கொஞ்சமா முடிஞ்சதை நம்மளால பண்ணும்போது இந்த எர்த்தோட பவர் சோர்ஸை நம்மளால காப்பாற்றிக்க முடியும். இன்னொரு கவலைக்கிடமான ஒரு விஷயத்த நான் இங்க சொல்லியே ஆகணும். என்ன அப்படின்னா ஹியூமன் பீயிங் தோன்றினதுலேருந்தே இந்த நாள் வரைக்குமே கிட்டத்தட்ட 30% ஆஃப் எர்த்ல இருக்க ஃபாரஸ்ட்டை வெட்டி எடுத்திருக்கான். இது எந்த அளவுக்கு வருத்தப்படக்கூடிய ஒரு விஷயம் அப்படின்னா கிரீன்லாந்து எல்லாருக்குமே தெரியும்னு நினைக்கிறேன். கிரீன்லாந்தோட மொத்த பரப்பளவையே அந்த அளவுக்கு கொண்டு வரலாம். கிரீன்லாந்தோட மொத்த பரப்பளவுக்கு இருக்கக்கூடிய ஃபாரஸ்ட்டை நம்ம வெட்டி சாத்திருக்கோம். அதுக்கப்புறமா இப்ப ரீசெண்டா நடந்த ஆஸ்திரேலியாவில் நடந்த இதை பத்தி கூட உங்களுக்கு தெரியும்னு நினைக்கிறேன். இந்த மாதிரி நம்மளோட பவர் சோர்ஸை நம்மளே அழிச்சிட்டு இருக்கோம். இந்த இதெல்லாம் தடுக்கிறதுக்கு பதிலாக நம்ம எலக்ட்ரிசிட்டி அதுக்கு தேவையான சோர்ஸை வந்து நம்ம இந்த மாதிரி சோலார் எனர்ஜி, லைட்னிங் எனர்ஜி, வாட்டர் எனர்ஜில வந்து நம்ம கொண்டு வர முடியும். இதுதான் என்னோட பிரசன்டேஷன். Thank you.
Thank you, Mr. Deepak. Now I request Ms. Devi Mano, Assistant Professor, Department of Computer Science, to make an announcement on events.
Good afternoon, ma'am. Good afternoon to everyone. An account of World Health Day, I would like to make an announcement on some of the competitions, which is open to all the students. First event, we have poster presentation, poster making. The theme of the poster making is restoring our earth to normalcy. Okay, the second event will be photography competition. The theme will be the Before Chennai biodiversity. Okay, now I will be presenting you the rules and regulations to be followed for the poster presentation as well as the photography competition.
Thank you, Manu ma'am. The success of every program is based on the outcome it is from the learners. Now we have question and answer session. I request the participants to ask their queries. Participants, please, you can ask your queries or leave your questions in the chat box.
I've left a question in the chat box.
Yes, is this Maithili Devadas?
Yes.
Yes.
Yeah. What is the
Okay.
timeline and criteria to assess whether the cubs are good to be released in the wild?
This was for Dr. Ramesh Krishnamurthy.
Maithili, this is. Can you hear me?
Yes, sir.
So I think the cubs are released in the wild is only when they start going away from mother. This like weaning away from mother. Usually at this age of 2 to 3 years old when they start dispersing away. So that's usually the right time to release them. So the other advantage and that age group is that they don't have the site fidelity, this emotional connection to the mother's territory. So much easier for them to adapt to new environment. Otherwise, there'll be a lot of emotional stress.
All right. Sir, I had another question.
Yeah.
Regarding the the cheetah reintroduction. I was just wondering if that would be a good idea considering the increasing human population and the constant fight for space by species which have large home ranges. And also both tigers and cheetahs are top predators in their ecosystem, and I assume that they would also require similar habitats or share the same space. And I had read somewhere when one species is eliminated, another species can take its place and play the same role for the ecosystem. So I was wondering if that would be the same case for tigers and cheetahs as well.
That's a very tough question to answer. The reason is sometimes the conservation is also not scientific, it's sometimes political. So I'll explain that later. But when it comes to the habitat per se, I think cheetah and tiger, they don't overlap so much because cheetah habitat is much more open habitat. Okay, whereas tiger requires much closed habitat. Even though tiger can live in the open habitat, but not as a preferred habitat. So if you look at from Indian context, is Gujarat, Rajasthan, it's a semi-arid area where cheetah you'll find. So I think those habitats have not been taken over by any top predator.
Okay.
We lost much of them to agriculture, and the remnant areas, maybe Gujarat, the small part we have lion. So I think the grasslands, whatever that exist in Rajasthan, Gujarat, probably top predator has not been taken over. So therefore, that kind of competition is not there. So, but the only thing that you talked about this challenge, given the increasing human population, things like that. Yeah, sometimes this conservation decision has a lot of reasons. It's not that straightforward.
It's more than just scientific.
It's more than just scientific, yeah.
Okay, thank you, sir.
Thank you, sir. Thank you, ma'am. Participants, do you have any queries? Participants? Okay, thank you. Now I request our principal, Dr. Mary Angeline, to share a few points on this session.
Good afternoon.
Good afternoon, ma'am.
Really happy to have Dr. Ramesh here on the platform for this webinar. Dr. Ramesh, hello.
Ma'am, your voice is not audible, ma'am.
Yeah. Oh, no, sorry. Good afternoon.
Good
Dr.
afternoon, ma'am.
Ramesh. Ramesh irukangala kelpinga.
I'm here. I'm
I
here.
hope you
Yes.
heard what I said.
Sorry.
Dr. Christopher Guna was the person who had referred your name, sir, for this particular webinar. The topic
I know him.
yours.
Correct.
Yes, okay. So he conveys his regards to you. Thank you so much. It was very valuable information that you have shared with us. And now we would go on to the vote of thanks.
Yes, ma'am. I request Ms. Christina Miracle Ratna to propose a vote of thanks.
Very good afternoon. On behalf of Nazareth College of Arts and Science and Department of Applied Zoology and University of Madras, I feel honored and privileged to propose a vote of thanks. On behalf of the management, we express our deep sense of gratitude and sincere thanks to our guest speaker, Dr. Ramesh. Thank you, sir. I convey my regards and a happy thanks to Dr. R. Krishnamurthy, Head Department of Applied Geology, University of Madras. I express my thanks to our Secretary, Sir Mr. A. N. Henry Morris, for his support. Our happy thanks to our Principal Madam, Dr. Mary Angelin, for her motivation. But the last but not the least, I thank all the participants for their active participation. Thank you and have a nice day.
I would request the participants and guests to please come on video so that we can take a photograph. I request the organizing committee to do the needful, please. Mrs. Mano, please come on video. Okay, thank you. So we have one question. Can you take up that question, sir? Mr. Nandadeep, yes. Can you please ask the question?
Yes, ma'am. Sir spoke about coral reef this morning. So instead of coral reef, I saw this news from TV about a month or so. They said about bananas, ma'am. That the soil of our ground is having some kind of anomalous properties, which is actually making banana go extinct. They say that within some years that we may not have a species called banana to eat anymore. Is there any research or something being done to save the species of banana that we eat today?
To whom is this question directed to, Mr. Nandadeep? Whom is this question directed to? Mr. Nandadeep, can you hear me? Okay.
Here's network problem.
Okay, Dr. Ramesh or any one of the resource persons can answer this to this question.
I'm not sure about this actually.
Even I am not related to this field.
Okay, thank you. Mr.
Okay, sir.
Nandadeep, we'll get back to you on this answer. Don't worry, we will send you the message. We'll get the answer to your question. Thank you anyways for joining us.
Okay, thank you everyone for making your presence. Hope the session was fruitful. Hope to meet you all tomorrow. Thank you all.
Okay, thank you very much. Thank
Have
you.
a great day.
Thank you.
Thank you,
All the
Mr.
best.
Murthy,
Thank
sir.
you very much.
Thank you for your support.
Bye-bye.